Today I'm going to go through thermal processes for physics. Yep. If you are my student, you can take out your pen, pencil, and foolscap paper or notebook. There's going to be a lot of writing. And if you are not my student, you can ask questions in the website or the Google form in the description below. Okay, let's start. Okay, so let's clear some basic concepts first. The first thing is thermal process basically just means transfer of heat. Okay, so it's simply that transfer of heat, and we're going to learn a few processes whereby heat is transferred. Okay, now the next thing is thermal equilibrium. Now, thermal equilibrium means there is no net heat transfer. Okay, no net transfer of heat. So my students, please write this sentence down. Thermal equilibrium is reached when there is no net. So the next question is there transfer of heat? Yes, there's transfer of heat, but there is no net. That means for every $1 I'm giving you, you're also giving me back $1. So it's the same. Okay, but there is still heat transferred. I'm still giving you money, you're still giving me money, but just that there is no net gain from my end, no net gain from your end too. Okay, that's thermal equilibrium. Now the second thing is standard wording is commonly used in your explanations. So do write. Okay, heat is transferred from a region of higher temperature to a region of lower temperature until thermal equilibrium is reached. Okay, once you're done writing these sentences, you can continue to the next portion. If not, you can pause the video. So now we are going into the main section of this topic, thermal processes. There are mainly three sections: conduction, convection, and radiation. You're supposed to memorize the wordings and tweak the underlined words according to the question. You know, the question will have different applications, different characters. Use those. Okay, but the gist of the explanation wordings are the same. Okay, so now I shall start with the first one, conduction. Now, for conduction, there are two kinds of methods of heat transfer. One is just simply conduction. The other one is free electron diffusion. Okay, so you need to know that conductions are available in both non-metals and metals, while free electron diffusion is only available for metals only. Okay, I say again, conduction is available for both metals and non-metals. Free electron diffusion is available for metals only. Okay, so now the wordings for conduction. Okay, you can start writing. Okay, when particles at the hotter end of the rod. Okay, again, this rod, depending on the question, it can be a rod, plane, plank, whichever item. Okay, so when particles at the hotter end of the rod gain energy and vibrate more vigorously, they collide and transfer energy to the neighboring particles. This process repeats until the cooler end of the rod is heated by conduction, or the heat is transferred to the cooler end of the rod by conduction, whichever. Okay. Once you're done writing, we move on to the next part. Okay, for free electron diffusion, it's similar, just that the electrons can move instead of vibrate. Okay, so when electrons at the hotter end gain energy, okay, and move faster, they collide and transfer energy to the neighboring particles. Okay, as they move to the cooler end of the rod. Now, this process repeats until heat is transferred to the cooler end of the rod by free electron diffusion. Okay, you can pause the video and write down. If not, we'll move on. Now, the common questions that come out in addition to the wordings, asking for the wordings, right, in the previous slide, is this: why metals transfer heat faster or better than non-metals? Okay, with that, you can explain that metals transfer heat by conduction and free electron diffusion, which is the two methods mentioned just now, while non-metals transfer heat by conduction only. Okay, so this you need to write this sentence down to get used. They are commonly asked for 1 to 2 marks. Now the next one is why liquids or gases are poorer conductors than solids. Okay, for conduction. Okay, so you say particles in liquid/gases are further apart than in solids. Okay, slower heat transfer by conduction. Okay, you can elaborate more whether the particles vibrate or transfer less or collide less frequently and therefore blah blah blah. Okay, depending on the marks. If it's 1 mark, this is sufficient. Okay, next we're going to go through convection. Now for convection, there are two kinds of wordings. One is how they make the room or the container or the liquid or the air in an area cold, and the other one is how it makes it hot. Okay, and remember there's no such thing as coldness absorption in physics. It's usually heat transfer. So heat is transfer away or transfer to the object or the liquid or fluid. Okay, so here goes. Now explain how the water is heated. Okay, it can be the air, the whatever is heated. Okay, it needs to be liquid or air, liquid or gas. I mean, yeah. Okay, so how is it heated? You can write that down. Or depending on the question, it can be water or gas. Okay, you can change the water anywhere. So the water near the heating element is gains heat and expands. Okay, first part gains heat and expands. The warmer, denser water rises, and the cooler, less dense water sinks to take its place. Sinks to take its place. Now, convection current is set up, heated by convection current. Okay. Now, you can pause the video and write at least the keywords. Okay. Next thing, how the room is cooled by an air conditioner. Okay, similar. Okay, just that we write it in opposite order. Okay. So the air near the air conditioner is cooled and contracts. Cooler, denser air sinks. Warmer, less dense air rises to take its place. Convection current setup, cooled by convection current. Okay, you can pause the video to finish writing. Okay, you need to memorize these words. Okay, they are marks. And once done, you can move on. The last section of thermal processes, which is the transfer of heat by radiation. Okay, and by definition, the transfer of heat is the emission by radiation is the transfer of heat by emission of infrared radiation without requiring a material medium. Means that you can transfer heat through vacuum. Okay, that's how the Earth gets heated up by the sun. And some keywords to know is that dull black surfaces are good emitters or absorbers of heat. Okay, this one depending on the question, you only use the applicable one. Shiny silvery surfaces are poor emitters or good reflectors of heat. Again, depending on the question. So write all the underlined, highlighted items, and when you're done, I'll move on. Okay, basically, we have an example. So, for example, on a hot day, your hair will be hotter than your skin because the dull black surfaces are good absorbers of heat, your hair, your black hair or something. Okay, then shiny silvery surfaces. You can say that the inner surface of the thermal flask are shiny because they are good reflectors of heat. They reflect heat back into the hot water that is stored in the thermal flask. Okay, so with those examples, do only write the applicable portion, and that's all for thermal processes.